So let's continue our discussion of special right triangles where in this video we're going to look at the 30, 60, 90 right triangle. And remember that this right triangle is really just half of an equilateral triangle. So if we had started with an equilateral triangle and we just split it directly down the middle, the resulting half of that equilateral triangle is this 30, 60, 90 triangle. Since remember, essentially this would just be the exact same triangle since we split it in half. And in equilateral triangles, the angles are all 60 degrees. So this angle at the top here, when you add these together, you do get 60. And also remember with equilateral triangles that the side lengths are all equal to each other. So if, let's say, we call this A, then this would be A, and this entire side here would be A. And since we're just focusing on the right half, this white triangle with the blue angles, this side length here would be half of the total because, again, it's split in half. So these two are equal to each other, which makes this A over 2. And to figure out the length of this height of the triangle, we need to use the Pythagorean theorem. So let me redraw this without the extra half of this triangle. But if you want to understand the pattern, you do need to understand that this is half of an equilateral triangle. So let me quickly redraw this. And with this 30, 60, 90 triangle, we figured out that this length here is essentially twice this bottom length here. And instead of using A, I'm actually going to change this to the letter D, since we're going to use the Pythagorean theorem, and that's typically written as A squared plus B squared is equal to C squared. So I don't want to confuse the lettering here. And we can call this letter, or this side length, whatever letter we want. So let's call it D, and this side here would be half of that. So the side length that is opposite the 30-degree angle is always half the hypotenuse. And again, that's because this triangle is half of an equilateral triangle, and so this bottom side gets split in exactly 2. And what we need to do is figure out this length here, this height of the triangle. And we can call this, again, whatever letter we want since we're going to solve for it. But let's call it x. And remember the Pythagorean theorem that when you have a right triangle and the legs of the triangle are A and B, that when you square the legs and add them together, it's equal to the hypotenuse squared. So after labeling these A, B, and C, we can just plug them in and set up our relationship. So we get x squared, that is A, and honestly, we can switch A and B if we want, that doesn't matter. As long as A and B are the legs, and C has to be the hypotenuse. So B, that is D squared over 2 squared, or let me just write it more explicitly. We're taking this fraction and we're squaring it, and this is equal to D squared. So from here, we just need to simplify this and solve the equation for x. So let's work up here. We have x squared plus d over 2 squared. So that's d over 2 times d over 2. So we're going to get d squared over 2 squared, which is 4. And this is equal to d squared. And we'll have to subtract this from both sides. So we get x squared. We're subtracting d squared over 4 on each side. So we get d squared minus d squared over 4. And since we're subtracting a fraction, we need a common denominator, and we can just use 4. So I'll multiply top and bottom by 4 here. And we get that x squared is 4d squared minus 1d squared, which is 3d squared. And that's over 4. And at this point, we're just going to take a square root of each side. And when we take the square root of x squared, that's just equal to x. And over here, we can separate this into a bunch of individual square roots since we have a product and a quotient. So when you have a quotient, you're taking the square root of the top and the bottom separately. So we definitely get the square root of 4 in the denominator, and up top we get the square root of 3 times d squared, but I'm actually going to give them each their own square root because, again, this is a product here. And this we can simplify further. So let me just make a little bit more room so that we can completely simplify this. And what we get is that this height here of the triangle is the square root of 3 multiplied by d over 2. So we can put that in, that this height right here is just root 3 d over 2. And with this, we now have the relationship between the side lengths in a 30, 60, 90 triangle. So let me just draw a picture again where it's a little bit cleaner looking. So if we call the long side of this triangle D, or whatever letter we want, then the shortest side, the one opposite the 30-degree angle, this is half that hypotenuse. And what we found is that this remaining side that's opposite the 60-degree angle is we take the short side and we multiply it by the square root of 3. So again, this is the relationship between the three side lengths in a 30, 60, 90 triangle. And we can use this relationship to find side lengths much quicker so that we don't always have to use this Pythagorean theorem. So let me show you a quick example. I'll just copy this and we can look at a blank space.